Hi, Miriam.
Hi.
I asked you to come because I was looking at fire safety and facade design, and I'm just reading about this terrible accident that happened in London in 2017. I don't know if you were aware.
No, I'm not. What happened?
So there was a very deadly fire that killed more than 70 people. The tower burned for more than 60 hours. And the reason why I'm showing this is because the facade design was identified as one of the main causes why the fire spread so quickly and it was so deadly. And it was because the facade was both ventilated, but so it had a ventilated cavity, which already often poses a hazard, but also the materials used, in this case insulation, were not the appropriate one. The standard is very strict in defining the combustibility limits of facade materials. So many things to take into account.
Yeah, I see. But I'm just thinking about our facade design.
Right.
Did we already respect it?
I think we didn't look into that yet.
I think we should talk to an expert.
I think I know someone. Shall we go and ask him?
Yes, we should.
Let's go.
Definitely. Yeah.
Hello, I'm here with our fire expert, Björn Peters. Thank you very much for...
Welcome. Yeah.
As you know, we are working on a new facade design, and the other day we just realized we haven't done anything for fire safety yet, our mistake. So that's why we're here to have a bit of an overarching discussion to structure our work. I will start with my first question. How would you summarize the main challenges in facade performance in terms of fire safety?
Well, I think we need to realize that in the past, fire safety in facades wasn't really a problem because we were used to make brickwork facades with just a few windows inside, or maybe natural stone buildings if you even go more into history. And then fire propagation along a facade wasn't really a problem. It was just a problem of fire igniting inside a room and a whole room being devastatedly destroyed by a fire, and not really the facade itself was just something that got also destroyed afterwards. If you look at the current day practice, then there are a lot of new materials being used inside facades. So that could be sustainable materials, but also all kind of new techniques or green facades. You could think of building integrated PV panels, which don't only introduce new materials inside facades, but also ignition sources. And that means that looking into facades regarding fire safety is actually a totally new way we need to explore and need to investigate.
So we could say that to some extent before it was just a problem of limiting fire propagation, but nowadays because of advances in facade technologies, we're integrating more advanced components, as you said, the PV or HVAC components, and this creates a potential ignition source. So it's propagation, but also effectively assessment of the potential of the fire, of the facade to catch fire itself. You mentioned fire propagation. Is there any difference across countries?
Yeah, there's a different requirement in each country because each country is allowed to have their own requirements. And there's a specific difference between the German way of testing this, according to the DIN code, and the European way of testing this, according to the European code. And the problem is actually that the classifications look quite similar. So in Germany, you've got a B1 and a B2 classification, whereas the European code also talks about an A, A1, A2, B, C, D, E classification. But they're not the same because it's a totally different test method. So you really need to be aware in what country you want to use a specific material or a specific facade in this case, and what criteria and what test method applies.
So we said propagation and potential of ignition. How do you assess if a facade is a risk in this sense, or if its design in a safe manner to contain these two?
It actually is combined in an overall risk assessment for a building. So it should be part of the overall fire safety concept of a building. So of course it makes difference if you have a building which has a low risk on fire or has all kind of other mitigating measures like a sprinkler installation or maybe has totally no combustible materials in the facade, then of course the risk is very low, and then you can reduce the amount of measures needed. But if those risks turn higher because you use, for instance, sustainable materials, which of course are mostly combustible,
Bio-based, for instance.
of bio-based materials, which are mostly combustible, that introduces a new fire propagation path within the facade. And well, actually, the thing is that we really don't know yet how these new materials in facades perform. That's because there's not that much tested. As I said, building practice was based on non-combustible materials, and there we know how everything works. But with these new techniques and new materials, we just don't know. So actually, there's a big need for more testing.
So we are lacking the data on the performance of many materials that are already in the market to build facades, but they haven't been really fully characterized in terms of fire performance.
On one hand, yes, at least not in their total configuration as a facade. So there are a lot of materials that just have been assessed by the material itself. So there's a small-scale test proving that the fire propagation class of a material is quite good, which is an A or a B classification, according to the European code. But that's a small-scale test, only performed at the material itself. And for a facade, it's of course a combination of all kinds of materials coming together, and they perform together in a different manner. So if there's a cavity inside the facade, the cavity could work like a chimney, and then fire propagation can be enhanced because of the chimney there. So it's not only looking at the materials themselves, but it's looking at whole facades. And as said, the normal way of looking at this in most European countries is just assessing it with a small-scale test, because that's an easy test to do, and that gives you some information on how a material would perform. But for a facade, it might not really be the best way of assessing facades, because in practice, a fire would ignite inside a building, develop into a full-scale fire in flashover conditions, as we call that, and that means that external flames would occur, and then on a whole level, external flames would actually attack the facade. And that's a total different situation than what's tested in the small-scale test.
Because in a small-scale test, what we are testing is we are effectively putting an ignition source in the facade catches fire, but from a geometrical perspective, dimension, but also, say, potential pathways then of propagation is different because you don't have a full scale set up there.
Yeah, it's actually the scale which is different, and it's the actual power of the fire source, because that makes a very big difference in how a facade can perform.
Of course, I guess there's some potential situation in terms of firepower are just not feasible to be tested in an experiment, or maybe yes, but they require a very intensive experimental process.
Yeah, it's actually a combination. As I said, we lack data at the moment, but if there would be more data, then you would also have the possibility of doing an expert judgment based on the data you have available. But then with all those new kind of materials and techniques, well, as said, there's lack of data, and we don't have the information yet to make a really well-assessed expert judgment.
So in terms of experimental testing, you said that the most common test at the moment is at room level. But how does it work then in this test? You put inside a small-scale facade? Usually what size?
Well, in the test it's normally a 1 meter wide and 1.5 meter high specimen. And then there's a corner adjacent to it, which has like a 0.5 meter wide and 1.5 meter high specimen, because you want to see how it performs at the connection. And then there's just a small fire in the basement of that corner. And then we just look at how the fire propagates along the facade. And how the materials used in that facade contribute to the actual file development and the power of the fire.
Okay, the relation between the source of fire and also how then it developed and increased power, I guess, depending on the combustibility of the
materials,
facade.
but also the configuration. Because, for instance, a wooden facade, which is totally closed, will perform totally different from a wooden facade with all kind of small wooden elements with gaps in between. Because then the exposed surface of the material gets bigger. And if there's more combustible material exposed, then the contribute to the overall fire would be bigger as well.
And if this test is not enough, do you see in your current daily practice the potential test in larger experiments, or this is something that still it's in research rather than?
Well, there's actually a research program going on now within the European Union to see what kind of mid-scale or big-scale test would be the right test for these kind of
New facades.
new facades. The problem is actually that all different countries within the European Union have their own say in what they want to test and how they want to test things. It's just regulated that they are all using the same principles. So actually, based on the Grenfell fire, there's a lot of commotion going on how facades should be tested. And all the countries that only had a small scale test are now looking into a bigger scale test to actually, well, predict the behavior of those kind of facades with these kind of tests. And the other thing is that in general, where we can easily simulate a fire grow with a computer model in a room, there's really a lot of lack of data for how this works in facades, also because they're all different. And there have been a lot of tries to fit simulation results with experimental results, but that needed so much tweaking in the simulations that there's not really a product or software available that you could use to really predict
everything
that could happen in a facade.
Effectively, with any other performance criteria, any experiment or simulation is done according to the boundary condition that we set, and this will never cover all the potential possibilities. So I guess that is why it's important in the design process that a facade engineer speaks to a fire expert to evaluate where the data is missing and if potentially some tests can be done, what test or what assessment makes sense for that specific project or design.
Yeah, I think so. And what a good way of looking at this is that you actually do a risk assessment of the facade itself and then see what kind of possible fire trajectories might be there within the detail you're developing. So just look into all kind of, just by drawing arrows actually in the detail from one side from a room to another or to the outside, see what kind of materials you pass alongside, and then just think of what could happen if that material or that structure catches fire.
So to recap these two steps, first there is the risk assessment at building level in terms of also what hazard is in the building and what is potentially power of the fire. And the potential, of course, effects that a fire happening in that building would have on society, losses and so on. And that also usually is performed at building level, correct?
Yeah, that's correct. Yeah.
So, and then it's always the fire expert that comes into play in the workflow to advise on that aspect of, let's say, risk of the overall building.
Well, it's not really necessary if it's a very common solution. But if you're really making a new facade, then it's really something that should be looked into. Yeah.
And then when we are at the level that the facade engineer has in mind the technology, the final detail or design, if it's a common solution, probably there is already enough information to explain the potential risk fire performance. Otherwise, the facade engineer has a consultation with a fire expert on the specific detail or material assembly, I guess.
Yeah, and then they together develop a detail that could also be tested, because of course these tests do cost money, so you don't want to test more than necessary. So that means that you really have to think of what are you going to test. Is this test representative for the whole facade I want to I want to develop? And based on what you expect, of course, you can also take some mitigating measures already to be sure that the test will succeed.
Of course, yeah, makes sense. Okay, thank you very much. I think with this we have some very good starting point for our design.
Okay.
Thanks.
You're welcome.